Hey, welcome back to your favorite technical mathematics class. We're going to look at some basic geometric figures. So we're into geometry in chapter 6. So let's talk, there's quite a bit of vocabulary here. Let's talk about what geometry means. So that comes from the Greek word geo, which means earth, and metro meaning measurement. So it's a branch of mathematics that deals with spatial relationships. Architecture is a good example, and some others there. Point. So we've got I think we all know what a point is, but it's represented with the little dot there. But it has no length, width, or thickness. A line, same thing, no thickness on this line. It's in infinite length. You've got a plane there. So if you might want to think about a chalkboard, or a whiteboard, it's extended in all directions as like a plane, except there's no thickness to it. We've got here a line. So the first one here, line AB. So you notice that the line AB with the notation for the line above it, whereas a half line is represented as a half line. Now notice it does not include point A, whereas a ray AB, this is filled in right there. Ray AB includes the point A right there. And a line segment AB, and the half line just goes in one direction, as well as the ray. They just go in one direction. The difference between the half line is it does not include the point A. Ray does include point A. That's filled in, if you will. Line segment just stops. It just stops. It doesn't go in either direction there. Now an angle, there's a bunch of different ways to name an angle. You can name it with the vertex. You can just say angle B. Or you can name it with the interior angle, that angle 1, so you can say angle 1. Or you can name it with the points on the initial and terminal side of the angles. You can say angle A, B, C. The vertex has got to be in the middle though, so you're going from A, B to C. Or you can say angle C, B, A. But again, that vertex has got to be in the middle there. So that's your 4 ways to name an angle. Angles are measured by the amount of rotation from the initial side to the terminal side. So if you're starting with a ray, and how much do you rotate? Let's say you rotate 60 degrees. That's your angle in there, 60 degrees. So we measure those in degrees. We also measure them in radians, but we're not going to deal with that today. There's 360 degrees for a full rotation all the way around, for a full rotation, 360 degrees. So 1 degree, if you rotate just 1 degree, it's 1/360th of the way around. And if you're measuring degrees, if you want to get more precise, for every degree, it's made up of 60 what's called minutes. So if I blow up this 1 degree here, let me blow that 1 degree up real big here. Here's 1 degree. Well, it takes 60 minutes in here. So 60 of these, if I can make a minute. So 1 minute is 1/60th of a degree. Okay. And there's also, we don't deal with the seconds, but there's also 60 seconds in every minute. Okay, so for example, this 78.7 degrees, you can express that as in degrees and minutes. So 78.7 degrees. So the 78 degrees is fine. You're still adding in 0.7 degrees. This is the one you got to take care of, that 0.7 degrees. So you just make a conversion. You say, well, for I have 0.7 degrees, and for every degree there's 60 minutes. Notice the minutes cancel. And so now that we got 60 times that 0.7 right there, which gives us 42. So this ends up being 78 degrees, and then again this is 0.7 times 60 is 42 minutes. And so you just write it 78 degrees, 42 minutes. Okay, let's do the second one, 95.3 degrees. So 95.3 degrees, that's 95 degrees plus 0.3 degrees. This is fine, so you leave the 95 degrees alone, but you got to convert that 0.3 part, the portion of a degree, you got to convert to minutes. So there's 60 minutes for every degree, so that your degrees cancel. And now you've got 0.3 times 60, which is 18 minutes. And so you write that 95 degrees, 18 minutes. Now let's go the other way around. How about 159 degrees, 15 minutes? 159 degrees, 15 minutes. Let's do that as a decimal. So the 159 degrees is fine, but now we got to take this 15 minutes and we got to convert that to degrees. Oops. So for every 1 degree, there's 60 minutes. That's a slash right there. So the slashes are gone, the minutes are gone. So you have 159 degrees, and then 15 divided by 60. Right? You have 15 times 1 is 15, 1 times 60 is 60. 15 divided by 60 is at 0.25. So 0.25 degrees. So that ends up being 159.25 degrees total. So 159 degrees 15 minutes is the same as 159.25 degrees. Let's do this very last one here. 127 degrees 36 minutes. See, 127 degrees is fine. You got to convert the 36 minutes into degrees. So for every degree, there's 60 minutes. The minutes cancel. So this ends up being 36 over 60, which is 0.6. So it's 127 plus 0.6. So 127 oh dude, come on, 0.6 degrees, 127.6 degrees. 36 divided by 60 is 0.6. Okay, let's move on here to classification of triangles. You can classify them by side. So if you have two side lengths that are the same, notice you have a slash here, slash there. So you got two sides. This one, if this is 3 feet, that'd be 3 feet. That's an isosceles triangle if you have two sides the same. If you have three sides the same, maybe that's 5 feet, 5 feet, 5 feet. That's an equilateral triangle. Whereas if you have all three sides different, you know, maybe this is 3, that's 5, that's 6, or whatever. That's a scalene triangle. Now, if you have a right triangle, so you have that, see that 90-degree mark in there? You have a right triangle. The two sides that are adjacent to the right triangle are called legs, and the side opposite the right triangle is called your hypotenuse. Okay. So here's some characteristics of these four-sided quadrilaterals. So if you have a parallelogram as a type of quadrilateral, and specifically a parallelogram, the opposite sides are parallel. So that one is parallel to that one, and this one is parallel to that one. So the opposite sides are parallel, and they have the same measure, the opposite angles. A rhombus means all four sides are the same, so all of them are the same, and it's a parallelogram, meaning the opposite sides are parallel. That one's parallel to that one, this one's parallel to that one. A rectangle is a parallelogram. It's got 4 right angles though, so 4 90-degree angles, opposite sides equal, opposite sides parallel. Square, all 4 sides equal, and you got the 90 degrees in there. Trapezoid just means you have only one pair of opposite sides that are equal. The other ones are parallel on that. Alright, so a circle. Circle means it's the set of all points that are an equidistant from a point. So if you got a center here, there's a point. All these points are equal, the equal measurement from the center. And if you were to draw all of them, soon enough you'd get the circle. They're all equal distance, which we call the radius. Maybe our radius is 3 feet. The diameter is double the radius. That's if this is 3 feet, that's 3 feet. Then the diameter would be 6 feet. Okay, so the diameter goes through the center of the circle there. Find the radius. Well, if this is all the way across is 40, then half of that from here to here would just be 20. Half of it. All right, that'd be the radius of the circle. Well, thanks for listening. We'll move on to 6-2.